The essential question for this lesson is, how do you identify local and absolute extrema? Absolute sometimes also called global, and extrema sometimes called extreme values. So how do you identify local and global extreme values of a function? Extreme values are maximums and minimums. And when we think about the difference between local and absolute, local is going to be the highest for maximum or the lowest for minimum y values on a small interval. And that's what local means if you think about your local newspaper or the local news or the local hospital, the local library. Those are all things that are on a small interval of geography in a small town or something like that. So that's what a local max or min, sometimes we call them, are highest and lowest y values on a small interval. Think the highest point in America, Alaska, has Mount McKinley, and that's the highest mountain in America. Mount McKinley is roughly 20,000 feet high. All right, that would be our local maximum, our highest point in America. Now, we know that that's not the highest point in the world. Okay, so the highest point in the world would be the absolute maximum. That's the highest or the lowest y value, going back to functions, highest or the lowest y value for the entire function. Thinking back to our example, Mount McKinley in Alaska is not the highest point for the entire world. Think the whole Earth. That belongs to Mount Everest at just over 29,000 feet, the highest point on the Earth. So there's no higher point than the absolute maximum. Likewise, if we think about lowest points, there's no lowest point. There's no point lower than the absolute minimum. Lowest point in America is Death Valley in California. Lowest point in the world are the banks of the Dead Sea in the Middle East, just for your reference. Taking a look at the graph that you should have on your handout there, let's try and identify some extreme values, maximums and minimums. Assuming that the graph extends down here forever and up here forever, making that assumption, if we look at the direction that this graph goes, right here, if we can put a point right here, that is going to be the highest point. That's going to be a maximum point. You can see it's higher than all the points on either side of it. That's a maximum. And this point down here, if I can get it to draw right there, is a minimum. That's the lowest point compared to points around it. All right, now the question is, are those local max and mins, or are they absolute max and mins? Well, you can tell by sort of analyzing the way that this graph, this is going to go up forever. So if we think this is the absolute maximum point, there can't be any points that have a higher y value than that point. Well, it's clear to see that there's points over here, and as this continues to go up forever, the y values will get higher and higher, and so this is simply a local maximum. Likewise, this portion of our graph goes down forever, and we're going to get more and more negative y values for our points, and so this minimum here must simply be a local minimum. All right, sometimes we would say the local minimum is y equals -6, and that happens at x equals 4. Or sometimes we'll just say simply the point 4, -6 is a local min. Okay, that's one way to write that. Likewise up here, the local maximum we could say is y equals 4, and that happens at x equals -2. Or we could simply say the point -2, 4. Let's try that again. -2, 4 is a local max. Okay, so that's how we analyze the graph. You're comparing each point to the points to the left of it and to the right of it. Is it higher than the points? Is it lower than the points? Is it the highest out of the whole function? Is it the lowest out of the whole function? Will help you determine local versus absolute. Your calculator has a feature called the second trace is the calculate menu, and this is a step-by-step procedure for identifying local minimum and maximum values using your calculator. Let's take a look at an example with that. Go to the y equals on your calculator, and we're going to put in this function f of x equals x minus 3 squared plus 1. That should look like a quadratic function in vertex form. You can probably already anticipate a little bit of what the graph's going to look like. Do a zoom 3 in order to get a standard viewing window. I'm sorry, zoom 6 gets us a standard viewing window. And we've got a parabola, and you can tell by analyzing this graph there is a point roughly right here that looks to be about a minimum compared to the points around it. And so what we want to do is figure out what that point is and identify it, whether it's a minimum or a maximum, whether it's local or absolute. The way we do that following the keystrokes is we're going to do second trace to take us to the calc menu. In the calc menu, you've got these two options, number 3 and number 4, minimum and maximum. The point that we just looked at looked like it was a minimum, so we're going to choose 3. And the calculator is going to walk you through a series of questions. The first one being, what's the left bound of your minimum value? So here's the minimum we think. We want to get our cursor somewhere here on the graph to the left of where we think the minimum is. So use your left and your right arrows to get your cursor to be somewhere to the left of where you think the minimum is, and then hit enter. The question's then going to become, where's the right bound? Again, use your right and left arrows to get your cursor over to somewhere to the right of where you think the minimum is. Hit enter. And the last question is to guess where we think the minimum is. Get your cursor as close as you can to where you think the minimum is and hit enter again. The calculator will then calculate what that point is. And knowing what we know about vertex form of an equation, of a quadratic equation, we know that hk is the vertex. And based on our h and our k in our equation, our vertex should be the point 3, 1. And now look at the answer on the calculator. It says there's a minimum at this 2.9999978. The calculator, the way it calculates it, doesn't round it up to 3, even though that really should be the number 3. And then y equals 1. So it has this function has a minimum of y equals 1 at x equals 3. And you can follow the same procedure with second trace, which takes you to the calculate menu to find maximum values as well. It's a left bound question, and then a right bound question, and then a guessing. And those are the 3 things you have to do in the calculator. Looking at the examples on the back of the page, we're going to try to identify minimums and maximums and whether they're local or absolute. And the first point we come to on this example is a point right here. It looks like 1, 2, 3, 4, looks like the point -4, -1. And as you can see, if you compare just to the points to the left of it and just to the points to the right of it, that's a maximum value. And now we have to decide, is it the highest maximum out of the entire function? We're going to assume this graph goes off the edges from where we can see, but clearly you can see there are points over here around x equals 4, 5, 6, 7, 8 that are higher than this point, this point 4, -1. So this is just a local maximum. It's local, it's a maximum to the points near it, but it's not the highest out of the entire function. And there's a point also right here, and that point looks like it's x equals 2, 1, 2, 3, 4, y equals -4, and that's a minimum point. It's lower than the points near it. Again, we have to ask ourselves, is it the absolute minimum, or are there points lower than that? Clearly over here, and as this graph goes to the left, down further, there are points lower y values than this y value of -4, so this is just a local minimum. Quick question, and that is, what's going on with this point right here? Is that a maximum point? And if you look at the points to the left of it, sure, it's higher than those points, but if you look at the points to the right of it, it is not higher than those points. It's the same value there. So that is not a particular point that's a local minimum or a maximum. We may be able to say that y equals 2, which are all of these points, are the absolute max for this function. This function has an absolute max of y equals 2 because all of those values, all of those points have the same y value. That's the highest that the graph will go if it continues horizontally. Now there's no one particular x that has that absolute maximum, but y equals 2 is the absolute max for this graph. So y equals 2 is the absolute maximum, and because this graph is pointing downward off the edge, there is no absolute minimum. If you think you can find an absolute minimum, keep going a little bit further and there'll be a point lower than that. Next example, we've got a point right here. What kind of a point does that look like? That looks like point 0, 0, and it is a minimum. Now, depending on what we think the graph does here, may determine whether this is an absolute min or just a local min. It's certainly local because it's all absolute minimums are local when you look at just their neighborhood. But is it an absolute or is it a local? We'll say this is local because we think that this part of the graph is going to keep going down lower and lower and lower. What about this point right here? That looks like the point 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 0.48. That's definitely a maximum. If you compare it to the points to the left and to the right, it's a maximum. But knowing that there's this portion of the graph that keeps going up, we know that's just a local maximum. And assuming that the graph goes up forever here and the graph goes down forever here, this is a graph that has no absolute extreme values, extrema. Just has a couple local. Last example here, we've got a minimum right here that looks like 1, 2, 3, 4, comma, -2. That's a minimum. All right, we're going to check to see, all right, this graph goes up there, it goes up there. This is an example of an absolute minimum. At no point will this function ever be lower than that point 4, -2. So that's the point that's the absolute minimum. We have another minimum, it looks like right here. That looks like it's the point 10, 2. All right, that's a minimum. We've already identified the absolute minimum as y equals -2, so this can't be the absolute. It's got to just be a local minimum, and you can check with the points near it. It's lower than they are, so that's a local minimum. And then this point here looks like it's the point 6, 4, that's definitely a maximum. It's higher than the points on the left and higher than the points on the right. But again, we've already said this goes up forever, so that must just simply be a local maximum, and therefore we can conclude about absolute maximum. This graph has no absolute max.